Good evening, everybody, as you shuffle into the room, as we might say. It's just on 7:30. We're going to give everyone about 3 to 5 minutes to just, get all their technology aligned and ready to watch before we actually sign things. In the meantime, I encourage you to say g'day as Eugene to everybody in the chat. Remember to turn your chat to post to everyone, of course, and we will be back with our webinar in about 5 minutes. By then we should have just about everybody on board. So welcome to you on this, what is a freezing night here in Melbourne. In all sorts of ways. Although I will say that the scooter revolution that we're getting with electric hire scooters and bikes is certainly going to change things and get the necessary regulations off the ground everywhere.
Yes.
So it's 7:35, so I think we'll officially start things off. Welcome, Tim. You may have gathered that is Tim Jones, our mentor for this evening. My name is Shane Murphy. I'm from IT Masters. I'm the Sales and Marketing Manager here, and I occasionally do the emceeing for these nights as well, the hosting. So I'd like to welcome you along tonight for our course. It's been presented by IT Masters in conjunction with Charles Sturt University. And it's apologies tonight from Jack, who does our usual emceeing. Jack does a much better job than me, but it's always fun to come along and hear what's going on. We're hoping that you are all safe and well, no matter which part of the world you're from. We're seeing a few people getting COVID again here in our part of the world. It seems to be popping up its ugly head, maybe because of the weather, who knows. We can see, as always, as we were discussing, people from everywhere in the world tonight, including Lesotho and other places. And as I said, your mentor tonight is Tim Jones. He's our adjunct lecturer at Charles Sturt. Thank you for making it on this March evening. I don't know where the weather is in your part of the world. As I mentioned before, it's cold and feels like it's winter already in Melbourne, and it's barely even into autumn. Hoping that you've got a nice balmy evening or morning wherever you are. Before we launch into it, do a little bit of the usual housekeeping. We encourage you to use the chat and ask questions during the webinar, and there's 2 methods to do so. If you've got a question that you want Tim to answer that addresses the actual course content, bung those questions in the Q&A section, and all of the other administration type stuff put into the into the chat. And Kit, who is here tonight to support everybody, will answer things as required. I think the question that everybody usually asks is, will the slides be available online? They will. And if you sign up to the course, you'll be able to get access to all of that sort of stuff. And also later on, you'll be able to see the webinar itself on YouTube. We'll have Q&A sessions periodically, or if something's particularly relevant, I might nudge Tim and we might answer it during the course of the discussion. As I said, Kit's here. Kit will give you all of those things, like the link that she's just put up in the course. That's the sort of stuff that will keep coming up as people ask. And I should remind you that this short course, this is a bit unusual for our short courses. Usually they are little chunks and tidbits out of our actual degree courses, our postgraduate degree courses. This is not. We took a decision a few months ago to do a couple of introductory short courses because we're seeing more people who are transitioning into information technology careers from completely outside places, and they've missed a bit of learning along the way about, what a computer is, how it works, how IP works, all of that sort of stuff. And so we decided to do a couple of 2-week short courses that give you some access to fundamentals, so that when you come into our postgrad courses or even our other short courses, you won't be bewildered by some of the content. And Tim has very kindly designed this course around the more general specifics, there's a term for you, the more general sort of things around what IT is, how the whole system holds together, what people do in their IT thing, and what various sections of IT mean, like IoT and cybersecurity and all that sort of stuff. So with that out of the way, I will hand over to Tim and enjoy the evening.
Thank you very much, Shane. Much appreciated. Now, just before we launch into this fully, as I said, we've got the question and answer that's available as well. And this always becomes a lot more fun for for everyone and a lot more interactive rather than it being a lecture type setup. If you have a question or a query around something that I'm talking about, pop it into the question and answer chat, because there's a good chance that someone else that is on the call is interested in the type of question that you're asking. And so we'll moderate these, and we'll have time at the end as well to answer questions, but we have essentially a cutoff of time. So if you have thoughts about a question as something comes up, by all means put it in there, and we'll have time throughout the evening to stop and answer some of those questions as well. Okay, so launching into this, we're covering an array of topics following on from what we went through last week. So last week was around what the basics of enterprise IT is, of working in an IT workspace, what the technology looks like, and bits and pieces. This is an extension to that of further technology areas, and an extension beyond the core IT arena into some other spaces. So we'll go into those, and hopefully, again, this is some areas that'll garner some conversation and some questions that'll come up out of it. Now, first of all, we've got IT process and governance. All right, so this is an area which I work in my professional job, my day job, as an IT architect. My role is as an enterprise architect, and the idea behind that is mapping out how multiple different applications and infrastructure and capabilities within an organization talk to each other. Right, so that's it from the technical side of having a high level view of how these applications work with each other. But a large part of the role of architecture and dealing within an IT organization is working in the IT process and governance space. Now, what this means is all of the process you have within your business function for IT to actually manage the support, the maintainability, and the rollout of new and existing applications as you require across the space. So without this function, you run into some significant problems. We'll go into those in a second, but it's an important role and is a specific process-based role in many organizations for the different types of process that have been put in place as well. So it's possible to have an IT aligned career, that you're part of an IT organization, but not necessarily be a technology expert. There's plenty of process and governance based roles as well. All right, so what some key things to think of in regards to IT governance and process management? One of the key things is looking at change management. All right, so this is important for any industry area, but in particular within enterprise information technology. Now, within a normal organization, we see applications get implemented within an organization, and the standard lifespan for the infrastructure and the application piece is somewhere around 3 to 6 years. So that means that once you put something in place, you're touching that in a significant way every 3 to 6 years. And you also need to manage the process of maintaining the infrastructure and applications and things like that that work with it as well. All right, so this requires a rigorous process around how you deploy that change, how you manage it, how you make sure that what you're putting in place as far as new or updated capability, or even if you're just patching operating systems and things like that, is done with careful planning and with a capability of being able to roll back any change. What that means is if you are planning to put in place a software upgrade for a particular database or some other system, that if there's any problems with it, you need to be able to undo those changes, and that'll allow you to get back to square one and work out what's gone wrong. Because the important thing is to make sure that the business function of the application is available the next day. All right. Another key point is around disaster recovery and business continuity planning. All right. So what this is talking about is making sure that the applications that the business is using to do their day-to-day jobs, whether that is around marketing or sales or resource planning or anything else that you might have as far as applications that support business function, we need to make sure that in the case of a disaster or an outage or something going wrong, that we've got the capability to recover from that. Now, that might be that that if you're in a banking situation where you need people to be able to withdraw money through ATMs, the requirement to recover from disaster is pretty much immediate. You need to have double systems essentially that are fully redundant and automatic failovers and the capability to recover very quickly. Because if you don't, you end up in the news the next day. All right, and we see that on a regular basis in Australia and around the world, that when there is an outage in a major bank, we saw one, I think, in 2021 at National Australia Bank, where their ATMs and their credit card facilities were offline for, I think, 9 hours or something like that due to a failure in their mainframe systems. And that was major news the next day as far as keeping track of that sort of thing. So being able to make sure that your systems come back again and being able to plan for that is important. Now, there's a slight differential between disaster recovery and business continuity planning. So business continuity planning is making sure that you've got things in place for anything that might happen to the business and the process and all of that sort of thing around applications and people. And so it might include things like your branch offices and what happens in the case of an earthquake or other natural disaster. Disaster recovery is specifically around IT. So disaster recovery is more or less a subset of business continuity planning overall, but they're often used interchangeably with each other. Now, as part of how we manage this process of how we deal with change and implementing new capabilities for our organization, there's the idea of review boards within large-scale enterprise organizations. Now, if you've got an organization of perhaps 500 people or less, you probably won't have review boards. This is much more towards the enterprise size of the organizational scale. But there's things like change review boards, architecture review boards, and strategic review boards. So a change review board is a selection of technology and business people that will review what is planned to be changed in the IT space on a particular night or a particular week. And they'll get some understanding, make sure that the people have done the requisite planning, allow it to go ahead, and or knock it back if there isn't enough information or there isn't a proper rollback plan. Architecture review boards are for when you're looking to put in place large-scale change across multiple systems or implementing new technology into the organization, making sure that that we're not doubling up something that's already there, or there's a view from the architects in the room as to whether there's a better way or more capable way of dealing with that sort of thing. And then we've got strategic review boards. This is where we have the senior executives or the chief technology officer, chief architects, that sort of thing, have a view about long-term planning for the organization. And this is where we might see something like an organization choosing to move towards a predominantly cloud-based approach to how they're dealing with infrastructure and systems in the organization. As an example of that, there's a board level review that went through the annual reports for Telstra, which is a major telecommunications company, the biggest telecommunications company in Australia. And their requirement for their information systems is to have 90% of the applications in the cloud by 2025. So that's a strategic move for how they're managing their systems, and help steer the ship for the architecture and the underlying management of their environments overall. Okay, so why is it important, right? So why is this important to organizations and why should they care? Right, so if we don't have process in place, there's chaos. Right, so if we allow people to make changes without any oversight, then people will make changes that they think are okay without the ability to back out of the changes, or doing changes in a way that impact users when they're trying to use the line of business application. All right, so we need to have controls in place to make sure that we've got that we meet the requirements of our clients, and our clients in an enterprise IT organization is the internal or external users of the systems, and making sure that they've got the access to the applications that they expect. The other big thing is that we're dealing with very complex systems. That complexity leads to interactions, again, that are unknown or unknowable from a mix of technologies, and that implementing change on enterprise systems can be problematic, complex, require involvement of multiple outside contractors to make sure that we've got all of those things correct. It's key to also remember that we want to plan to avoid failure, right? So if you fail to plan, you plan to fail, right? So we want to have that planning in place to make sure that people are aware of what's going on, and making sure that we know how the technology is going to be impacted by the change, what time we expect the application to be unavailable, allows us to communicate through to end users and other stakeholders to make sure that those systems are working as well. Right, and the other key thing to remember is that documentation of all of this sort of stuff, from the architecture through to the processes of how we deploy technology within the organization, whether it's change or new architectures, or implementing some updated resilience within the organization. Documentation provides a clear view that people can understand what's being changed. But there's also a level to this of making sure that we document things, that we have things like an email trail or an acceptance of what we're looking to put forwards. And this is what we term as the CYA, which is cover your ass, right? So it's important not only to technically be correct when we're going through and implementing change within an organization, but you also need to have some political awareness when you're dealing with change within the organization, because if you're given the go-ahead from someone but you don't have it in writing and things go badly, then you can be scapegoated, and you want to avoid that as much as possible. So if someone's asking you to make a live change to a production database in the middle of the day and they say it's really important, always make sure that you've got a written response of what the expectation is there, right? So that if it goes badly, you can point to someone else. All right. So that takes us to the end of the introduction to governance and IT process. So I'll just check in with you, Shane. Is there anything in the chat or questions at this point?
Nothing in the questions at the moment. Oh, here we go. Actually, something has just popped in as we speak. Question, how to verify that the architecture deployed is the best with regard to cybersecurity, business continuity, backup, etc., etc. I think the question is, how do you know that the architecture you've got is right, really? Which seems like a long piece of string.
No, that's the core of architecture. So the idea with especially when you're dealing with new systems, new capabilities, you want to make sure that you've investigated different options. And again, that you've documented that you've investigated different options, because if you go ahead with just a single selection and something goes wrong, again, you want to come back to that CYA moment, whether you're an architect or whether you're an engineer or whether you're a process person or anything like that, that you want to have documented that you went through a thoughtful process around how you plan and choose an appropriate technology for being deployed. Sometimes it'll be, and I've been in this situation, that a technology is selected because someone has successfully sold the technology to a senior executive in the organization, and the senior executive has said, we are implementing this, and you just need to work out how to do it. And that becomes part of your documentation, is that the reason we're in this mess is because someone's signed off on something. But if we, generally speaking, from an architecture perspective, what we're given as architects is the business problem and the requirements from the business of what they expect for the deployment of new technology. And so that'll be in the forms of functional and non-functional requirements. So functional requirements are the things that we expect the system to do. So if it's a new order taking system, that we expect it to have any number of clients, that it has the capability to have 1 million different widgets sitting in the environment, and that we expect it to be able to provide that information using security to both end users and internal clients. So as an example, non-functional requirements are about how it operates. So this is where we might have as a non-functional requirement that we need the system to be available 24 hours a day, that we can't have any major outages as part of it, that sort of thing. And so as an architect, we take that information, we look at what the options are in the marketplace. One of the options that we should always look at when we're looking to deploy new technology is do nothing. You know, the status quo is a reasonable approach, and being able to document what it means if we do nothing. It may be that there's cost. It may be that that we lose competitive edge. It may be that we're at significant risk of data loss or something like that. So, but do nothing is always an option. But based upon the requirements that we get, there might be multiple different solutions in different areas that we can utilize. So again, we analyze that. We provide the information. We use, in an enterprise sense, we would use an architecture review board as a sounding board with our thoughts around how we're meeting those functional and non-functional requirements as part of our documentation, that people would be able to comment or come up with new ideas or mention that we've got some existing systems that support that. But this whole process helps lead towards a cogent response to what the client would have, right? And the client can be an internal business executive or someone else from an external party, whatever the case may be. Right. So, so that's basically it is that if you follow the process fully, and if you're interested in architectural process, doing some study into the areas of TOGAF is recommended, because the process for building an architecture there is reasonably exhaustive around some of those steps that I've covered. But if you follow that process, then you have some trust that you'll end up with a good result, or at least you'll have the documentation to make sure that a bad result wasn't your fault. Okay. Does that answer that off, you think, Shane?
I think it has indeed. And at the moment, there's no other questions. There's somebody asking about their login password. I'm sure we can figure that out separately.
Yep. Awesome. Thanks very much, Shane. All right. So now launching into cybersecurity. Now, there's multiple areas that we see as far as threats to an organization. All right. And one of the biggest, which has become more and more prevalent, that we're seeing impact daily lives of people these days, is nation state actors. So we're seeing indictments of of hackers from the likes of North Korea, China, Russia, Belarus, in America and other countries for their nefarious actions against large-scale systems. Right? So this comes across in various ways, whether it's sowing chaos, misinformation, or other types of damage to websites, to systems, bringing down the CIA public website as an embarrassment, or going through and doing misinformation campaigns utilizing social media. So we see that sort of thing, especially with the likes of the FSB and other related parts of the Russian system against the Americans. But we are also seeing some significant risks from the likes of China against Australia, and for those countries from the likes of our intelligence agencies as well. Right? But it's become more and more rife that there's if you like, a cyber security arms race between countries of protecting important systems. All right. One of the other areas is around ransomware, and we're seeing that grow, in particularly from North Korea. All right. So this is a significant method, right? When you have a GDP of, I think it's like $4 billion or something like that, is the GDP of the entire country of North Korea. It is ridiculously small. And so anything you can do to bring additional money into the country is an amazing boon. And so they are using the training that's available within China to build their own hacking farms. And they're using that for doing ransomware attacks against the likes of hospitals, schools, organizations. A recent one that was taken down last year was the Garmin website. So I wear a Garmin watch, and that was offline for a couple of days because of a ransomware attack against them. And that is now becoming more and more common. We're also seeing some targeted infrastructure attacks, right? So we saw that in Ukraine, of Russia attacking some infrastructure systems as much as possible, and going back the other way as well. Now that's especially easy in that situation because they were using Russian technology, which was quite old in some of these areas. But we also have the capability or the concern that there's the ability for some of these sort of things to be used as a coordinated attack against a country, especially as part of a hot warfare. If you're able to use a combination of these things at the same time as hot warfare started between large-scale nation states, then it could be quite disastrous. Right? So being able to take food supply offline, water systems, flood valleys, all sorts of things. So nation-level cybersecurity is a big risk. Now, we also see professional cyber criminals. Right? One of the successful businesses, as far as successful goes, that has worked in this place is there's an organization that does ransomware as a service. So they give you all of the application pieces and the back-end systems and capability to build up an environment where you can run ransomware and botnet type systems. I'll talk about botnets in a second, but there's the capability to build this up, or to have hackers for hire for gaining access to other systems or targeting industrial espionage. So that sort of thing is worrisome, but not quite as worrying as the nation state actors. Right? So the nation state actors, in particular, large scale countries, the internal equivalent of the NSA in North America, Israel, Russia, China, etc. If they choose to attack, they have what we term as zero-day attacks. And what that means is they would have a collection, a library of ways that they can access public systems that haven't been disclosed to the likes of Microsoft or the Linux Foundation or anyone else. And so there's millions of systems out in the wild that are open to these environments. All right, so that's where, and they've also got the resources to spend a lot more time and effort to gain access to environments than what we would actually see from the likes of professional hackers. One of the other threats is physical security, not only for our data centers and making sure people can't get in there, but making sure that people can't get access to our office buildings, making sure that if phones or laptops are left on trains, or in planes, airport lounges, anything like that, that they're not accessible. Right? I remember, I think going back probably 15 years ago or something like that, there was an army officer that left a CD of confidential information in the Qantas lounge in Canberra. And that was quite an embarrassment, having unencrypted information that was left behind. And so physical security is around how people can physically get access to any parts of the environment, not just being able to break down doors or pick locks or anything like that. All right, so one of the other things that we see is phishing. So phishing is where you get people to click on a link within an email. All right, so this is something that is designed to install malware on the system, or get them to follow a link, or give information that allows them to gain access to systems. So phishing is where you'll send out perhaps an email to 100,000 people and hope that someone clicks it. And so this is often used to create a network of computers or systems that are compromised that people can utilize for other nefarious purposes. Spear phishing, on the other hand, is where you're actively targeting an individual. More effort's gone into it. You will structure emails in such a way that it looks like it's from a real person. There's one case where a spear phishing attack was launched against an individual in an accounts payable role, and they were convinced to send $1 million by wire to the wrong account because they received what looked like an invoice with correct information on there. They received a phone call from the person saying that it was important. So social engineering involved in that as well. And that sort of attack can cause significant problems. But that's where the last piece comes in, is the users within an organization. All right, so the users are often the weakest link in any organization from a security perspective, either because people use things like weak passwords, people leave their laptops unlocked, walk away from them, share information, that organizations in many cases have high levels of access for individuals that allow them to do much more than they need to do in their day-to-day job. All right, so many avenues lead to users being problematic. All right, so the old adage is that IT would be a much better job without the users. All right, so that's what we continue to see, that life would be much easier if you didn't have them that you had to deal with. Remember that there's an old, when I used to deal with first line support, there was a joking expression that we had for dealing with users, particularly if they called up with a dumb problem or something like that, and that's PEBCAC, which is problem exists between chair and keyboard. All right, so the it's an ongoing problem. All right, so key terms in regards to cybersecurity. What do we need to think about there? So first of all, there's asynchronous cryptography, synchronous cryptography, and public key cryptography, right? So these are different ways of securing information. Now, when we talk about asynchronous cryptography, what we're talking about is that we use a different key to lock something as we do unlock it. We'll go through and look what this looks like on the next slide. But basically, it's how a lot of the internet works. When you connect to a secure website, anything that starts with HTTPS, we are using SSL or TLS to access that website, and that's using asynchronous cryptography, which is also a type of public key cryptography, or rather public key cryptography is a type of asynchronous cryptography. When we're talking about synchronous, we're saying that we utilize the same key to lock something or to encrypt something, and we use the same key to unencrypt it. Now, an example of this is if you have a password on a Word document, you lock it using hello123 as your password. Don't use that as your password. That's not a good password, but we use hello123 to lock our Word document. Then when we try to open the document, it asks us for a password. Hello123 is the password that we use to unlock it. So that's synchronous cryptography, right? And they're important concepts, and they're the way that communication across the internet continually works, right? So we use asynchronous for those connection types, the public key cryptography. But once that connection is made, all of our traffic in the pipe utilizes synchronous because it's much faster. Right, so if you have some interest in this, I did my my master's in information system security back in 2007 with IT Masters, and so this was my area. Now, having said that, I'm not a security professional, but I certainly found that having more information about the security aspects, especially as I was already an IT professional at the time, rounding out both my resume and my knowledge with security helped me immensely with my role. So it was certainly a whole bunch of interesting topics as part of it. Now, two-factor authentication or multi-factor authentication. So this is something you come across regularly, and this is what you see when you access a government website or something like that, where it asks you to put in a code that it sends through to your phone, right? So that's one type of two-factor authentication. There's multiple different types that we can have of that. So anything that uses multiple types of authentication is this type. So that could mean that it's utilizing your face, an iris scanner, your thumb, a password, something that comes through your phone, utilizing a code generator from the likes of RSA or the Google Authenticator or something else. So multiple different ways of doing this, but this provides us an extra layer of security. Another thing that we have within that world is a firewall. So this is something that you would have on your own home network. Pretty much every home network has this now, which protects your home network from the internet. Right, so it provides a separate network segment or a safe area on the network that shields systems from being able to be accessed directly from the internet, because even a standard laptop that we have might not have all of its patching up to date, and could be vulnerable if it was sitting raw on the internet or in a public space. And so a firewall is always very worthwhile for assisting with that. Now, exploits. So exploits are what are used by hackers to gain access to a system. So this is some sort of bug or problem with a particular piece of software that allows people to gain some type of access to the system. Now, the way that exploits are utilized, it's usually that there's a toe in the door is all that's required to escalate privilege or capability, and to move from one system to another and expand, land and expand from a hacker perspective. One of the things that is super important of understanding security as well is the 3 A's, and that's authentication, authorization, and accounting. So authentication is what we do when we log into Google Mail. right? So that we put in our password and it authenticates that we are us. Authorization is what then allows us to get access to our individual mailbox. So we have access to that because we're authenticated, and we're then authorized to access the emails that are part of our system. Now, accounting is another important part of this, especially for an enterprise organization, because what this does is gives us the ability to track who actually accessed that, or where did they access that from. So if we're running a secure system, for example, and we're getting 1 million accesses for a certain person's login per second, right? So there's lots and lots of access for an individual user. If we don't have any accounting in place, we won't know that that's happening. And anyone that is able to see that accounting information of what's been accessed on a particular user would realize that there's some form of brute force attack going on against a particular user's account on a system. So accounting is important to realize who accessed what when, but also to help identify if there's an individual that's been attacked. So botnet, we described on the previous page, the ability to get people to click on a link and install something that allows a hacker to gain access to their system in the future. Now, this is often what makes up part of a botnet network. Right? So the botnets are essentially systems that remain on 24/7. People have them logged into the internet, and they just run normally. But there's now basically a backdoor into that system, so that they can do some processing, or they can do what we'd term as a distributed denial of service attack against a system. Right? So we could use that network either for doing crypto mining, potentially using the CPU to run through things, or we can again use it for further attacking or some other way. We've got hackers as part of what we deal with, and we've got white hat and black hat hackers. So this is a term taken from 1950s cowboy movies. Right? So anyone that had a black hat in the show was a bad guy, and if we had John Wayne, they would be wearing a white hat, they were the good guy. And so you would know in those movies who was the bad guy, who was the good guy. In the case of hackers, a white hat person is someone who does security research or accessing of systems or testing of environments with the view of making the internet a more secure space. All right, so they're not looking to gain any advantage, but they're looking to use it for research or providing information through, or helping find vulnerabilities and making people aware of them. Black hat on the other side are the bad guys. Right? And then we've got the various different things that are used to infect your computer. So we've got malware, which is a general term for bad things that get onto your computer. A worm is something that gets onto your computer and then will try to propagate to other systems, either on your local network or elsewhere. We've got viruses, which basically can infect your computer and make something bad happen. We've got Trojan horses, where you might download software from some place that's a bit dodgy, and they've got some form of malware in the application as well. So the application might run completely fine, but it's also installed something in the back door. And then we've got spyware, which is basically being able to look at things like keystrokes. It might be that the application keeps track of user heuristics or something else. So we, again, see some bad actors in that sort of space of organizations that would create software but keep track of various other things. And this is one of the areas where people in the security space are worried with applications like TikTok, where an application is owned by essentially the Chinese government, and that there's a view that users' information could be tracked or other access gained. Now, when we look at public key cryptography, this is essentially what's happening in the back end. Right? So this is This is how we gain access to websites and things like that. We have a public key, which is available to everyone, and that is used to encrypt information. And then we've got a private key that only the recipient has access to, and they can then unencrypt the information that's come through with that. All right. We'll cover this a little bit more when we go through quantum computing a little later. One last thing as part of security goes, anyone that's found any of these topics, hopefully not too confusing, but have interest in this space, I can't recommend this podcast enough. I absolutely enjoy it. He puts out great content and covers interviews with both white hat and black hat hackers of what people have done and the sort of attacks that can occur on the internet as part of keeping things secure as well. All right, so Shane, it looks like we've got a few questions that have come through.
Yeah. Code's asking, what's the best way to prevent or secure your environment when a user has clicked on a phishing email link?
All right, so it really depends upon where the link takes you. All right, so a phishing email, a few of the ones that I've seen will try to get you to, will take you to the likes of Facebook or your financial organization. So I've seen one come through from my bank. I've seen that linked a toll road company here in Australia. There's lots and lots of phishing SMSs that come through from them, not from them, but from bad actors. And in those cases, what they're looking for is your login information. What they're trying to access is your login details. So I've also had it where I've seen ones where they try to gain access to your Facebook information. So they're looking to take over Facebook accounts and things like that. So first of all, being aware of the security impacts and that sort of thing is the first step. So there are no banks or financial organizations in Australia that will send you a link to click on in an SMS. Right? So this is one of the attacks and vectors that we're seeing as highly prevalent at the moment, is that SMS is how a lot of phishing is actually occurring right now. Right? So there's no reason that you need to click on that. If you receive a message from something and it looks legitimate, go to their official website and check the information there, or call them. All right. So so if you can, avoid the situation in the first place. Now, secondly, if you do click it and it comes up with a login page, don't log in. All right. So just because you click on a website, it's unlikely to cause you any damage. It's unlikely to be able to put in place any major Trojans or anything like that. Gone are the days where you could be easily attacked and installed just by hitting the wrong website, particularly on mobile. There's a fair bit of protection there. So clicking on a link itself is unlikely to cause you any damage. The key is if you realize that you've been sent to the wrong address, or they're trying to send you to an address, don't put your login information in there, close it off, and you should be okay. Now, if it's some other sort of attack, it really depends upon what it is. But if you've put in your password information or something and you realize, change your passwords, etc. People will use things like Facebook logins for ripping people off on Facebook Marketplace, or for sending out spam messages to a whole bunch of people, or for trying to attract and attack people in other ways. Right? But yeah, try to be aware. But the way that these things usually operate is it'll come up and ask you for your login information, and the If you put that in, it'll automatically send you through to the real site and automatically log you on with that information as well. Or it'll just pass you through and you'll think that you've put in the wrong username and password and it won't log you in, and you'll be none the wiser. So awareness is really key. If you're not aware of the attack and they're successful, there's probably not much you can do until you realize that you've been hacked by getting messages from people or some other way.
Yeah, I think that probably answers Thomas's question as well. Saladin has asked, if you cascade 2 different types of firewalls of different brands in the network, is that a good practice to try and use it as a multiple filters, I would imagine?
Yeah, so I mean, that's we have that by default with the way that most organizations work. So any laptop or computer that people use these days generally has some sort of firewall built into it. And we're normally sitting on a network segment that also has a firewall there. So multiple layers of security are good, but they don't protect us from everything. So if we've got, so the multiple different types of firewalls can mean that we end up with something that's more difficult to manage. So from an enterprise perspective, where you have a large range of rules and applications and things for how you open up those systems to the internet, utilizing multiple different types of firewall would be a nightmare to manage. So it wouldn't be best practice, because even if there was some small advantage through obfuscation or separation, or making sure that a particular type of firewall doesn't have a vulnerability against it and you're protecting against this very small case, the extra complexity that you're adding to the environment means that your environment is less secure, because less people know exactly what's happening with your security stance. You need to implement your security rules in 2 places rather than just one, which means that things will be missed, things will be forgotten, and you'll end up in a worse place.
I think that's it for the questions just for the moment.
Cool.
We go.
All right. Now, looking at artificial intelligence and machine learning now. All right.
Certainly buzz topics of the day, if ever there was.
First of all, I'll get people to put in the chat if they can recognize all of the movies that I've got here with machine learning or artificial intelligences that people might be aware of. Now, the portrayal of artificial intelligences is usually not a good thing in most movies. I think that some of the most one of the most generous sort of artificial intelligence type portrayals recently was Joaquin Phoenix with Her, and that implementation is something that we're starting to see is being quite realistic. They're currently now, with the advent just over the last few months of new versions of ChatGPT in particular, we're seeing that there are some people that are starting to form emotional bonds with the artificial intelligences. All right, so it's getting interesting. All right, so what have we got? iRobot, Terminator, RoboCop. Yeah, and someone's got Space Odyssey there as well. All right, so well done. We've got all the movies. But the risks that are bound in the movies aren't the type of risks that we're seeing in the real world. All right, so the major risks, I covered this to a certain degree last week. The major risk is around societal change of having robots or capabilities that do or automate a lot of the work which is done by individuals at the moment. Means that there's potentially less jobs. There's always opportunity with change, but it means that we don't have tens of thousands of people in large cities that pick up horse poo anymore, because the motor car did away with the street cleaners and the stablers and all of that sort of thing. So that sort of change led to new roles, new capabilities, but those people were out of a job. What we're starting to see the potential of with artificial intelligence is that there might just not be enough jobs anymore. Right? So if we've got automation to carry out a whole bunch of functions that are currently done by white collar or blue collar workers, we can run into some societal changes, and we need to work out what sort of society we want that to look like. So that means not only people need to live, people need to earn money, but people also need to find meaning in the world. Right? So probably a little bit of an esoteric view from a technology talk, but where these are things that need to be wrestled with over the next 10 years or so. Now, from a terminology perspective, so artificial intelligence is what we term as the ability of something to act in an intelligent manner, or what we would term as an intelligent manner. Right? So there's a very famous computer science, didn't cover him last week, but the father of modern IT or modern computers is a guy called Alan Turing. So he created the first research paper that talked about creating a general purpose computer. Right? So incredibly brilliant man, very sad end to his life, but he also did amazing work during World War II with cracking the Enigma code, the cryptography that was used by the Germans. So, but one of the things that he also came up with was the Turing test. Right? And the Turing test was basically, if you're receiving type responses from someone that just come up on a teletext or a screen or something like that, can a person tell by asking a number of questions whether the person on the other end is a computer or a person? And if they can't tell whether a computer is a computer or a person, it passes the Turing test. And we're kind of there at the moment, right? That you can have a real conversation with an artificial intelligence. There's certain blind spots that they have, but the capability of them, especially the creativity, the ability to use them in a meaningful way, is moving forwards now in leaps and bounds after spending many years as a curiosity or something that wasn't really that useful. So artificial intelligence is the ability to do the creative side of work, to build something out of nothing. Right? Machine learning, on the other side, is a subset of artificial intelligence. It's sort of a type of artificial intelligence, but is a bit different in that we're using algorithms to find meaning out of data. Right? So this is the ability to look at images, or look at Excel spreadsheets or large databases or combinations of things, and to be able to draw out information from what is just raw data normally. We see this sort of thing with the ability for even entry-level security cameras that you can get, being able to identify a human or an individual person, and being able to do things like unlock doors based upon facial recognition of them coming up and that sort of thing. So we also see that in the next couple of areas of being utilized in business for being able to derive information from large sets of data. So one of the things that has become an important part of IT over the last 10 years is what's termed as big data. Right? So this is very large data sets. So we see this especially when we're looking at internet scale applications, whether it's Instagram or Netflix, Facebook, but also across data that we see with that's created by governments or other methods. So it's basically a big set of data that, and the general way that we gain access to systems is to be able to work our way through things like databases and being able to pull information out of there. Now, machine learning and other methodologies with these very large data sets enables us to find meaning out of these large systems and to be able to derive new insights into what we have. Now, data lake is the big daddy of big data. Right? So this is where basically we have a collection of information of disparate types. So it's basically just a whole hodgepodge of information. But it might be, for example, if we are running a distributed network environment, if we are the national broadband network, for example, and we have information about the uptime of all of the modems on the network. We have information in some separate databases about our the rollouts of all of our technicians. We also have some weather, rain, and temperature information that goes 24/7 over the last few years. And we have some humidity sensors in all of our fiber pits across the network. We would be able to correlate all of that information together using machine learning and the data lake of being able to pull all of that into a cogent response and let us know, for example, that when we're alerted that there's going to be a large rain event, we need to call out a whole bunch more of our technicians and make sure they're available to update change or something along those sort of lines. Being able to solve real business problems by being able to correlate and gain useful information out of very disparate data sets. The final one here is artificial general intelligence, right? So we're not there yet. There's been some, as I mentioned last week, there's someone from Google and a few other people that are saying that we think that there's certain applications that have reached sentience, but I don't think that we're there at the moment. But artificial general intelligence is when we build a machine that can think for itself, but also have the broad creativity of humanity. That's something that we can set any sort of task to, and it'll be able to work out how to do it. Now, one of the things that's postulated about that is essentially reaching a point of exponential growth when this becomes available. Because if you've got something that can answer its own questions, it can create the next version of itself reasonably rapidly and develop computer systems or other environments to help support that. And what that means is you end up with a spike or exponential growth in knowledge and capability and intelligence of these systems. But who knows where or when that'll come about. Now, an example, this is something that I pulled up. If anyone's interested in the full rundown on this, in the notes, in the PowerPoint slide, I've got the full back and forth between the two artificial intelligences. So they've got to a level where they've got a reasonable level of creativity at the moment in the systems. So someone went through and created a rap battle between ChatGPT, which is owned by OpenAI and now supported heavily by Microsoft. They've got exclusive use of it at the moment. And the other system here is Bard, which is the artificial intelligence which is made available by Google. Right? And so someone got them to do a rap battle between the two. Out of the two responses, I certainly think ChatGPT won with the punchiness of the lyrics and the capability to come back. But the prompt that got this to work for both of them was basically, let's have a rap battle in the style of Wild and Out, you versus me, and we'll take turns, keep the verses short, and you go first. So so that was basically it, and from there it built up a repertoire, and the information was plugged backwards and forwards into Bard and ChatGPT off the back of that. So pretty funny, but also quite interesting seeing just how creative they can be of creating brand new content based on a topic that you come up with, right? And I also utilize the tool myself. One of the things which it's quite helpful for is giving it some prompts around the type of stuff that we're working on tonight, and it helped create the quiz basically that's part of this course. So so it creates quite good questions and things like that as part of it. So quite helpful. All right. And now, before we head into that, just to check in with you, Shane.
Okay. There's a couple of questions here. What sort of jobs do you think are likely to be replaced by AI in the future?
I think that, like we've seen with a whole bunch of technology changes, I think that there are jobs that will continue as they've continued in the past, but certain aspects of the job will become much, much easier and require less people to manage it. An example of this is accounting or lawyers. So part of being a lawyer is to thoroughly check through things like contracts, to be able to make sure that there's no adverse clauses in there, to make sure that a contract matches up with the contract that you're putting in front of the other party, etc. Right? Being able to do that sort of drudge work of going through in deep detail contracts that can be hundreds of pages long is something which an AI will certainly be able to take advantage of. And what that means is, rather than having someone that's doing their articles or a solicitor or something like that go over this with a fine-tooth comb, they'll basically be checking over the work that the AI has done in minutes rather than a couple of days' work. Now, that means that there's still an absolute requirement for lawyers. I don't think lawyers are going away, but the job availability for that, the work that's required around that sort of thing will be much lower. Similarly with accounting, that you still want a human to deal with from an accounting perspective, to be able to explain your problems to be able to find creative ways of dealing with structuring your finances and assets and all of that sort of thing. But doing things like your tax returns or doing other functions, that there'll be less jobs for accountants in the future, because things like the software will be able to do a lot of the basic functions rather than requiring someone around that process level thing. And this is certainly something that I've seen when I was working in the banking sector just a few years ago. We started to see robot systems taking over from process level jobs within the bank. Now, these robots that we had are different from artificial intelligence, because some of the drudge work that we've done as part of things like the requests for a new loan and that sort of thing require information to come in basically through fax or email or some other way, someone to grab the information from there and type it into another system, and then pull information from another area and put it into another system. So these robots would basically be application systems that would read the application information and put it into the internal websites correctly and do away with a bunch of workers. So we saw that a few years ago. Artificial intelligence is going to supercharge that sort of change. So process type workers are the ones that are probably most at risk around it. So ironically, we've seen in the past, automation has seen blue collar workers being often the most impacted, and white collar workers being the biggest beneficiaries. I think we'll see the opposite come through with artificial intelligence.
I think that's actually all just for the minute. There's some other questions which are more general. We can come back to you later on.
Cool. Nice one.
Oh, actually, no, there's a new one. How far away do you think you are from an AGI?
Yeah, I'm not sure. So there's some of the I mentioned last week around Moore's law, which is the idea that the capacity of computer systems doubles every 18 months. Right? So the number of transistors within a CPU doubles every 18 months. Now, if we stretch that out, around 2042, we reach a point where the number of transistors within a single CPU roughly equals the number of neurons within a human brain. So the idea is that when we reach that point, it'll be possible to create a silicon version of a brain. We'll be able to simulate essentially the human brain in silicon form. Right? And once we can do that, we've essentially got a virtual artificial general intelligence we've replicated human capabilities within a system. Now, the other side of that is the application side. Now, what makes up intelligence and the capability to carry out general tasks and be able to interact with the world, it's still very complex. So the artificial intelligence that we have at the moment are essentially probability machines. Right? So they work out what word needs to come first in a sentence, and using a probabilistic algorithm, they work out what word comes next, and they simulate intelligence. So this is, in my opinion, not a pathway to true intelligence, but there's lots of other research projects that are going on around building things up. So yeah, so I'm going to say, I reckon probably somewhere between 2040, 2050, but it might be 5 years away. Who knows?
We're pretty much still in the land of, what was it called? Deep Blue, the chess computer that could beat humans just simply by being fast and calculating all the known probabilities.
Yeah. Although, having said that, the computer that was made to beat a human at Go, which was thought wouldn't be done until like 10 years from now, which I think succeeded in 2018. That was a different pathway than Deep Blue, because Deep Blue was just using huge amounts of data processing capability to work out the pathways out of where they are at the moment. Whereas the Go robot was able to come up with new and novel ways. Playing against the computer was completely different to playing against a human. So that was interesting, that we're seeing sort of emergent qualities out of these computer systems that are different to human intelligence as well.
It's good to see. I think we should move on.
Cool. Now, some of you may have heard about IoT, or the Internet of Things. So this is another area that we're starting to see build up and come about in the last few years. And this is off the back of low-cost computer systems and ubiquitous networks. Right? So it's basically the combination of sensors, processing, and internet connectivity. And this is used for the likes of, we're starting to see smart parking spaces in the city of Melbourne, where I live. We're starting to see things like the ability to have smart management of traffic and traffic signs and things like that. I know that the Los Angeles area has that sort of capability built in of systems that are connected to cameras, etc. And all of this comes together to create new capability for how we go about day-to-day lives. All right, so we're starting to see a lot of this technology become really cheap and accessible for creating smart homes and home automation capability. And we're starting to see it be utilized within large cities for automation, etc., as well, of of how they deliver services to their clients, right? So we have the likes of smart metering for electricity. We don't need to have someone come around and read our meters anymore, but it also gives us the ability to have an app where we can see live consumption, etc. Right? So not just on an individual basis, but large-scale connectivity capability. Now, one of the driving technologies, again, of this that we're seeing is 5G networking. And the reason why that's a driver is part of the specification for 5G is to provide ultra low power requirements for having a network connected device being able to be on the network. So we could have a battery powered device that would run off a very small solar cell or run off a battery for 6 months or something like that and be able to send information back to the network. It's not quite there at the moment because the way that 5G has been implemented in most places in the world right now is not utilizing the full specification. It's basically an extension to 4G at the moment, providing a bit faster speeds and capability. But within the next 10 years, we'll start to see some of those new capabilities of 5G coming along as well. All right. Now, we're running out of time. I'll move through into quantum computing now. So this won't be an in-depth view of quantum computing because it's quite a big topic in itself. But quantum computing is still a science experiment, right, to start with. So it's not something which is super useful for everyone at the moment. And it will never be something which you'll have in your mobile phone. We won't be changing the way that our processors work and having quantum computers sitting in there. I might end up eating my words in a few years, like the IBM executive that we spoke about last week did when he said that there's a global market for 5 computers or something like that. All right. So happy to eat my words if I'm wrong, but generally speaking, there's not a requirement for day-to-day users to have quantum computers. So again, it's a science experiment. It's very much built in academia at the moment. And there's also a lot of development and funding that comes from the likes of the NSA and other nations that are trying to race towards this sort of ability. Now, the reason why quantum computing is important is mostly around cryptography. We spoke about public key encryption earlier. And what this is basically using very large prime numbers, multiplying them together and utilizing that to build the public key and the private key out of that information. Now, one of the things that quantum computers are able to do really well is factor numbers and factor very large numbers potentially. And that means that if we have a big enough quantum computer, that we would be able to basically decrypt any traffic. Now, it's not just a matter of building larger or bigger things. The quantum states that are utilized for developing this is very unstable, and it's very difficult to build larger and larger systems and requires quite a lot of effort. Superconductors, very much ivory tower academic sort of things. But the area itself is very interesting. All right, so we're starting to see or continuing to see a lot of money come into this sort of space, and so we're seeing an expansion of this capability and multiple systems that are pushing into this space, and that they're rapidly increasing the capability of their environments as well. Now, what we're seeing as part of this is that there'll come a time when the number of qubits will support being able to decrypt current information which is sent out there. So we have the likes of the NSA and China and Russia and other large countries keeping a whole selection of data that's been farmed or collected because they know at some point in the future, they'll probably be able to decrypt the information. Now, the good news in the future is that there was a recent competition that was put in place to find a quantum resistant algorithm for securing data. And one of the things that's been come up with is a vector-based approach to how you deliver cryptography, and that looks like it would work reasonably well because it comes up with multiple answers. If you don't have the correct information, then you have unlimited ways of actually getting through. So at the moment, quantum computer, not directly associated with IT because it's not something that we see on a day-to-day basis, but it is a risk for the way that we deal with things in a secure manner, moving towards the future. And this is one of the areas, again, where we have an arms race. So there's an idea called quantum supremacy. And the idea is that if China or America or Russia get there first, then they'll be able to break all of the encryption that's available and use it to basically spy or gain access to systems, and it'll put everyone else in a mess. And that's why we have a bit of a race and a lot of money going into this sort of stuff.
I wonder if it will not be long before we see sort of publicly hosted quantum computers, so that while everyone may not have it on their wrist, we might have access to it if we specifically need it.
Yeah. Well, it's a sort of thing that that there's certainly research systems that are available in that sort of space. So you can have there are some cloud computing capabilities for doing quantum programming things, and so it's an interesting space, but very, very niche at the moment. All right, and I'll go through this. This is just the last small piece before we launch into some questions at the end. Just a small piece to finish on, which is what does the future hold? All right, so I don't think I've met or seen too many people that have successfully mapped out what the future exactly looks like. So there's a great technologist that mapped out a whole bunch of future capabilities based upon just that doubling of the chip capability that I mentioned earlier, and that he used that for being able to work out when computers would be able to do things like synthesize sound, be able to understand speech and that sort of thing. So there's certainly some good futurists out there, but it's certainly not something that's easy. Now, from a career perspective, though, one of the biggest things is we expect to see constant change, and it's accelerating. So over my entire career, I've seen a great deal of change. I've gone from carrying a whole bunch of magnetic tapes from a large computer room upstairs as part of my job to working with computers in the cloud and planning things out in that sort of way. So massive change in what we see, how it operates, and how we interact with systems as well. But it's key to remember, if you're interested in a career in IT, particularly on the technology side, you really need to be a lifelong learner, right? Whether that means that you do multiple certifications, whether that means that you join the likes of a master's course through IT Masters, if it means that you're just reading things. It's important to keep on top of things, be aware, make sure that you're both interested in what's coming through, but also make sure that you continue to be employable in the future. All right, so it's certainly a very changeable occupation and space to work. So if you like learning, it's fantastic. Now, what we'll also see is we have those things that we spoke about tonight of AI, IoT, cloud that we spoke about last week, and also new technologies like augmented reality, which Facebook or Meta have bet their whole company on being successful within the next few years. They'll continue to provide both opportunity and disruption. All right, so the key is that you want to make sure that whatever area that you're in, that you don't end up as those stablers from 1904 that have built your entire career around horses. You want to make sure that you're building your career and how you want to manage your future view of work and being interested in the world around something that's in line with the way that the world's changing, because it's changing faster and faster. All right, so on that, Shane, do we have some more questions?
We have a couple more questions, and I'm pretty much going to close them down in the next couple of minutes. So if you've got any, bung them in now, because we're getting close to the time that we had allocated for this evening. A couple of questions from all over the place. First one, do you think will be easier for hackers to get hold of companies if they can reprogram a company's AI?
Well, yeah, so it all comes down to where you put trust. So if someone manages to get access to an AI and especially as they become more generally useful. So one of the areas that could become very useful for large organizations is looking after infrastructure or resources using an AI, being able to keep track of systems. And as part of that, they would need to have high level of access to the environment. So if you have an AI which is set to manage large parts of your organization, or even one which is just used internally for asking questions, because you could, as part of getting advice from an AI, there's sensitive information that you can share with the AI that you wouldn't want your competitors to know about. So in all of those situations, you need that to be secure. So if it's in control of internal systems, it needs to be more secure than anything else you have in there, because it's essentially the keys to the kingdom. If you're using an online AI system, like the existing ChatGPT or something like that, there's been cases recently where chat histories of users were made available through a bug in their system. So it was insecure. People were able to get basically questions that people were asking, and that could be either personally or professionally embarrassing. So absolutely, the AI attacks or AI takeovers would be an excellent way either for industrial espionage or gaining access to systems.
Couple of questions about quantum. First is, what's a qubit, which I'd hazard a guess is possibly a quintillion bits, but is the excitement in quantum computing mostly just for decryption of secure systems?
So a qubit is basically the unit of measure within there. So a normal bit in the world of IT is a 1 or a 0. A qubit has essentially 4 states. So you can do more with it. It holds more information in a qubit than a normal bit, but it allows us to basically do a different type of algorithmic work than we would have with a normal standard computer. So what was the other part of that question?
The other part of the question was, is quantum computing basically just about decryption of secure systems? Is there any other real application?
Look, it allows us to have, there's different types of algorithms that you can use. So there's there's areas where it can be valuable, but you need to have a problem that really requires what it provides. So the biggest push and why there's a lot of investment at the moment is all around the cryptography. That push to quantum supremacy is a real thing, and a real concern for national security agencies that they don't get beaten by their enemies, essentially, in the cyber world. But there are plenty of other use cases that are difficult for standard computers, but become easy in the quantum world. But a lot of this is around reasonably esoteric mathematical type problems. So it's quite possible that it might be that people find a way to utilize quantum computers to make graphics cards work really fast or something like that, in which case there might be a push for them on the consumer market. But yeah, there's I'm not aware of too many use cases which have a direct correlation to standard sort of uses that people have.
I'm sure the use, if they build it, they will come.
Yeah.
Matthew was asking a more general question about how many hours a week do you think is useful to just keep studying and keep finding out stuff? Do you have a figure around that? We've spoken to him about, what happens with courses, but outside of courses.
Yeah, well, for me personally, I read a lot of stuff, like follow people on Twitter. I read things on Reddit. I follow some podcasts that I listen to on a regular basis. For example, the security one that I mentioned earlier. There's a lot of work-based courses or information sessions that I need to attend. But outside of that, I also go through and on a regular basis do things like certification. So the last certification, I became a TOGAF certified and a TOGAF certified instructor around being able to utilize the latest version of that for developing architectures. So this is a architectural framework, or the ability to create an architectural framework. And I find that for me personally, continuing to look at certifications gives me a goal and a milestone and something to aim at on a semi-regular basis. So looking to do one or two of those sort of things a year to both keep me intellectually engaged, but also with the view towards my own personal career, that you want to continue to be up to date and relevant to the marketplace should you become unemployed or want to go for a different role within your organization.
Absolutely. In fact, I should mention here that one of the things that IT Masters does is that we recognize a lot of standard industry certifications, things like TOGAF, although we're actually in the process of adding that to our list, or CCNA or CISP or CISM, all of those things that those who have any exposure to IT in those sorts of areas will know about, and we give people credits in their courses for them. So if you come to us and you've done a number of different certifications, it's always good to tell us about them, and then we can see if we can offer you some credit towards shortening your course and making it cheaper for you. And one of the ways you can do that is by looking at our eligibility form, which is on our website as well, as if you're interested in doing postgrad study further on. There is two more questions here, which we'll quickly go through. DeGamba has asked, what security tools are best for a distributed control system in the manufacturing industry? That might be a long answer, but.
Well, it's sort of like how long's a piece of string, because as I was mentioning earlier about how you develop an architecture and choose tools, it's very much dependent upon what the broad requirements are. So I'm not an expert in manufacturing systems, and it would really require research and knowledge around what the business needs.
And I think we'll end the discussion part with Samir's question, which is quite funny, really. It's how realistic is the Terminator scenario? Where are we going to get the AI-driven apocalypse?
Well, there's some people that are there's some quite smart people that are legitimately concerned about it. One of the concerns, I think I mentioned it last week, is that the OpenAI organization that created ChatGPT, they've put in place some controls around the use of AI and the way the intelligence operates. Their concern is that they've now got a lot of competitors coming to the marketplace that are developing things without those controls. And so we'll continue to see that occur. Now, the situation around do we expect an AI to take over the world? It's like, I don't personally rate it as highly likely. If you've ever seen a robot vacuum cleaner try to work its way down the stairs, it doesn't work well. But
especially doesn't like it if it gets entangled with pet waste.
Yes. Yep. Exactly. Yeah. You don't want one of them going around your room. So I personally don't see it as a major risk in that sense. I see it more as a risk on how we deal with the changing nature of work and how people deal with that in the real world.
I think I'd be more concerned about people asking AIs for advice and then getting wrong advice over an extended period of time. It'd be much more subtle and insidious as it went along without meaning to be. Could maybe take us down a bad track. That's a fun note to end on, isn't it? So yeah, look, we're going to finish up now. Thank you all for coming along. Big thanks to Kit for doing an excellent job moderating behind the scenes and just popping in information people on the chat. And to you too, Tim. It's been great to have these sessions. I think they've been really good and valuable as a slightly different course to our normal short courses, and just introducing people to IT. I think we've always marched along on an assumption that the people that do our IT graduate degrees are people who are already working in IT and know all this stuff, but it's nice to spread the news, so to speak. So I would hope that everybody has a fabulous next couple of days and a good holiday coming up in a couple of days' time on the weekend that we have here. And we'll look forward to seeing you at our next one in a few weeks. In early May, we're planning to do short courses on digital product management. And later on in the year, we're actually planning on doing one on the Internet of Things as well as an upcoming topic. But if you've got any interest in our topics, it would be good to fill out the survey, which is available on the system, and just tell us other things that you might like to have, as well as to contribute your views to what you have witnessed and heard tonight. We do take the surveys very seriously, and we try and mold what we do around feedback from everybody. So once again, thank you, good night, and good night.
Thank you all.
Thanks, Tim.